Hello everyone, this is Mingyang, and this is my video podcast. I got three coordinates, and this are how I named them. The first one is the Maldives Atolls, and the second one is point bars of the Mississippi River, and the Saudi Arabia's deserts region. Okay, so let's go to the first one, the Maldives Atolls. As can be seen from the figure, that this position is next to an atoll in the Maldives, like this place. Volcanic activity provided the initial high ground on which coral reefs could start to grow. Over time, as the volcanic island eroded and subsided, the coral reefs expanded upwards and outwards, eventually forming the atolls like this. Okay, so we have some sedimentary environment and rocks. So the Maldives sedimentary environment is primarily influenced by the marine setting, characterized by coral reefs, lagoons, and the ocean. The dominant sedimentary rocks and structures included the coral limestones. The islands and atolls mainly consist of the coral limestone, providing a structure foundation, and also the sand and the dead coral. So the white part, like this part, is sand, which is composed of broken biogenic materials such as crushed coral, foraminiferous, and also shells. The brown lines, like these lines, are probably composed of unbroken biogenic materials. This kind of breakage is usually caused by waves and weathering or the wind, and is transported to the coast by wind and waves for deposition. And also the biogenic sediments. The ocean floor around the Maldives is covered with biogenic sediments, essential for atoll formation and island building. So from 2001 to 2023, uh, although it doesn't look very obvious, some atolls look clear here and slightly larger. This shows that deposition is still proceeding slowly. Like this place, this place is larger than this place, so that's why. So some future speculations. The future of the Maldives is uncertain, primarily due to the trade of climate change and rising sea levels. Being one of the world's lowest lying countries, with an average ground level of just 1.5 meters above sea level, the Maldives is particularly vulnerable to the effects of sea level rise. Predictions suggest that continued global warming and ice cap melting could lead to a significant increase in sea levels, potentially submerging many of the Maldives islands within the century. Additionally, the health of coral reefs is crucial for the Maldives' future. Coral bleaching events caused by rising sea temperatures threaten the very foundation of the islands. So if it is not particularly affected, thermologically, this debris will continue to accumulate on the atolls and causing them atolls to become bigger, become larger. Okay, so now it's the second place, called point bars of the Mississippi River. So actually, this is point bar, this place, and we call this place the cut bank. Its location is in the United States of America. And formation is a point bar is a depositional feature made of aluminum and accumulates on the inside band of streams. It is low curved ridge of sand and gravel along the inner bank of a meandering stream. The point bar is formed through the slow accumulation of sediment deposited by the stream when its velocity drops along the inner bank. Point bars are deposited in abundance in mature or meandering streams. So this is a sedimentary environment and rocks for the point bar. So the deposits. There are some like sands, salts, and clays are transported from upstream and deposited as the river's velocity decreases. Also, sandstones, stones, and shales are formed. Sandstones formed from compacted sand-sized particles, common in river environments where water flow decrease and sediments settle. And the siltstone is composed of thinner particles than sandstone. So the siltstones form in quitter waters where fine sediments can settle. The clay and shells formed from very fine particles. These rocks often accumulate in slower moving parts of the river or in floodplain areas where fine sediments can settle out of the water. And we can say it's wide, so maybe there will also be some quarters. Uh, so the sedimentary structures. Common structures include the cross bedding and ripple marks, indicating the direction of the current flow, like this. So we can know the flow is in this way, and also sorting and grading. Well sorted well sorted sediments show a thinning upward sequence as the current slows. So we should talk about the historical development trajectory. From 1998 to 2024, we can see the river narrowed at the bend and more sediments floated here, like here to here, and this to this way to this part to this part. So it become narrowed. And also the future. So we talk about the future speculations. The cut bank, like this place will continue to be eroded and move to the upper left direction to this way. And the point bar will also become larger with continued deposition. And it will also become larger and become into this way. This part will become bigger. However, there might be some climate change impact or some else impact like the human activity impact. The climate change may lead to potential changes in sediment position patterns, and in that case, this may cause a change in terrain here. And now we have the last one, the Saudi Arabia's desert region. This is a desert located northwest of Saudi Arabia in the Arabian Peninsula. We can see the yellow sand like this and gray-white stones through the map, like these stones. This desert landscape is characterized by its arid environment, extreme temperatures, and sparse water resources. The region includes various topographical features, from sand dunes to gravel plains and rocky plateaus. Okay, so the sedimentary environment and rocks of the desert. The first is a Ionian sands. Much of the surface sediments in this desert are composed of Ionian sands. These sands are characterized by their fine grains, which have been transported by wind over long distance. The sands from large stone fields in the Robo-Kahia and Northwood deserts, which stone shapes and sizes varying widely based on local wind patterns. And the sandstone outcrops. In regions where sands have been cemented over time, sandstones outcomes occur. These rock formations can be seen in various parts of the Saudi deserts, showcasing the solidification of Asian sandstones into solid rock. The sandstone often contains cross-bedding structures indicate of the direction of Asian wind flow. And also the limestone. Limestone in parts of the Arabia Peninsula, limestone formed from the accumulation of marine organisms, shells, and cuttings, especially in historical periods when these areas were under shallow seas. So I'm going to introduce the dunes. A dune is a landform composed of wind or water-driven sand. So we have transverse zones here, like in this way, from here to here, this way, maybe this way, and also the longitudinal zones, like from here to here, this way, like from this way, and maybe this way. So we have to talk about the historical development of the Saudi Arabia's deserts. So the geological history of Saudi Arabia's desert region is marked by the transition from shallow marine to terrestrial environments over millions of years. This transition is reflected in the stratigraphic record, which shows a progression from marine sediments to continental deposits, such as sandstones and evaporites. The region's desertification has been influenced by global climatic shifts, particularly the onset of arid condition in the late Holocene. And also some future speculations for the desert. There might be the erosions and sedimentation, like the wind erosions, and also the tectonic activity, like the earthquake and faultings. Also the long-term geological processes, like the sedimentation, may this could lead to changes in the terrain of the desert. So that's all. Thank you very much.